everyone, thank you for showing interest in our product pass. Let me introduce you to our team AutonomousGuard at UCI. We are a group of software engineers working on enhancing security and safety of autonomous driving solutions. Our team has Nitesh and Shubham as backend developers, and I am Pallavi, principal engineer, and I have Aditya with me. He is the senior AD software engineer. Today, we will present our product pass and we will discuss the problems faced by the AD industry, why they occur, and how we have fixed them. We will discuss the workflow and different components of our solution, and finally, we will discuss the value that it adds. Self-driving vehicles are part of the current world that we live in and are only going to increase as we progress forward. With over 300 accidents involving autonomous vehicles in the past 2 years alone, people are concerned about safety and security. Only 16% of the people in United States are comfortable allowing a fully autonomous car to drive them. We believe that the AI algorithms used in these advanced solutions are vulnerable to adversarial attacks. There is a need for extensive research and development to identify and address safety and security gaps in the autonomous driving systems. Because of these gaps, road safety is compromised and it leads to accidents. The damages and repairs to these vehicles during testing is quite high. On an average, each bug in autonomous driving software costs around 4,000 to 16,000 US dollars. That's a quite high price to pay. And just in case the bug is found in an actually deployed vehicle, the reputation and sales can decrease.
We believe that AD systems are vulnerable to adversaries because they are tested without taking into account the diverse array of situations that could arise in actual on-road conditions. Extensive understanding of how self-driving vehicles operate and also knowledge of certain tools and simulators is necessary for creating test cases. Reliance on human intervention for upkeep and oversight leaves room for accidents and safety concerns. To overcome these problems, there are solutions available in the form of simulators like Carla, LGSVL, AD systems like Apollo, AutoWare, and more. These tools need to be integrated with the test scenarios. Setting up these configurations for each test scenario is itself a task that requires considerable effort. Furthermore, there are different test scenarios available on different papers which can be implemented as per your requirements. Each of these components may require different sets of expertise. There is no single solution that helps to bring all these configurations together. This is something we have solved in our solution. We present our solution PASS. It stands for Platform for Autonomous Driving Security and Safety. PASS is a comprehensive testing platform that has inbuilt testing scenarios which are implemented in Carla. These scenarios are built such that you can easily modify them as per your requirements. We have also provided our in-house AD software and integration with Apollo. This can serve as benchmarking tools for your testing. You can compare your results with ours and check the robustness of your solution. Let's now jump to the workflow for our solution. First, you do any customization to test the scenario as per your requirement. You can choose different types of maps, layouts, and weather conditions as needed. Second step would be to attach your preferred AD solution with the given commands. Now, you just run the simulation. The platform will create sensor data logs and simulation video which can be used to check and compare results. PASS is a command line tool, and to be able to configure it, you need to have basic knowledge of shell scripting, Docker, and Python programming language. Regarding hardware requirements, a decent system would have at least 32 GB RAM and around 200 GB disk space. You also need an adequate GPU for the tools to run. Now, let's jump to the architecture of PASS. We have developed a bridge which communicates with a simulator, let's say Carla, and gives control of the vehicle to the AD system. The test scenarios are added to the Carla before the addition of vehicles and other objects. This is done so that the whole environment is set before giving controls to the AD software. The system produces sensor data logs and video at a user-defined path. You can save this data for future reference.
Let's now talk about one of the attacks that we have added in PASS. As shown in these images, part of the stop sign on the left is obstructed by the bushes, and the middle one has graffiti on it and is completely different from a normal stop sign. The sensors in the car may not recognize them. With this scenario, we are testing the accuracy of the object detection algorithm in the AD software. Here is a snapshot of video captured while running the scenario. As you can see, the algorithm detects malicious stop sign with some accuracy. This is an example of a stop sign test scenario where the stop sign has graffiti on it in the simulation. We can see that the system detects the stop sign with a confidence of 61%. Using this as a benchmark, you can compare the results of the algorithms used by your AD solution. As mentioned earlier, we have also integrated Apollo, and we can see that the car is moving in both Apollo and Carla. Here the car is being controlled by Apollo. We hope all of this looks exciting to you.
Now let's discuss how all of this will benefit you. PASS helps to reduce the cost of resources needed to test these malicious test cases in AD systems. The infrastructure setup cost is also reduced as you can now utilize our work directly instead of figuring out the dependencies and getting stuck somewhere. PASS makes it easy to compare outputs of different algorithms for the same scenarios and helps make an informed decision. Last but not the least, all test scenarios can be easily modified and altered as per the requirements. Now that we are familiar with the benefits of PASS, let's analyze the growing demand for AD systems that could create billions of dollars in revenue. Consumers want access to AD features and are willing to pay for them, and based on their interest in these features and commercial solutions available on the market today. AD could generate between 300 billion and 400 billion in the passenger car market by 2035. We are confident that PASS will help you to make more reliable autonomous driving systems and achieve high compliance with safety standards and regulations. This will surely increase the customer base for your product. PASS caters to all levels of AD and thus can be a game changer for your business and help you become the market leader. This is just the beginning of adding security and safety in autonomous driving systems. We hope you found this presentation insightful. Please feel free to contact our team AutonomousGuard at UCI. We are looking forward to your feedback and concerns. We would appreciate it if you could fill out this form. The link is attached in the description of this video. Thank you for showing interest in our solution.